So Python, we understand it's a interpreted very high level. So it's a very high level language. The kind of data structures you have list, tuple, dictionary, set, all that inbuilt. And these are okay. These are dynamically typed. You don't declare variables. If I have to use X, I just assigned X 100. It becomes a int. And int happens to be a class. Everything in Python is a class. It's a totally object-oriented thing. And then once X was a integer, I can still reassign it to a string. And the data type of X will change from int to string. So that's what dynamically typed language means. That means I don't declare variables. I assign them value. They take a type based upon that. And I can assign them a different value. They can take a different type. You can have lists. List look like some entities enclosed in square brackets. So that highlighted thing is a list. It is also showcasing a for loop. So I can say for I in this list, print the square. Python doesn't have open and close brace. It is based upon indentation. So if I indent one level to the right, like this print I star I is indented one level to the right, that means it's inside the for loop. If I write print done, so because this print done is indented in the same level as for, so it is after for loop. It's not inside the for loop. So if I run it, you can see done is printed after the for loop. A dictionary looks something like this. In Python, a dictionary looks like something, this highlighted thing. So it's a key value pair. So assume this highlighted data structure is showing you age of people. So Ram has age 10, Sham has 12, and Mohan has 14. And I'm just looping through the dictionary. So when I loop through the dictionary, I want two variables. I want the key and I want the value. So that's why I'm writing k, v. And I'm saying that loop through this dictionary dot items. So what is this dot items? Dot items means I am invoking a method function of the object. So as I said, in Python, everything is an object. Everything is a object of some class. Int, string, bool, dictionary. So I'm invoking the items of the dictionary. So that's okay. I'm looping through everything and I print those things. Python is case sensitive. And if I give a wrong name, error mechanism in Python is exception based. The preferred error handling mechanism is exception based. So for example, if I have a list, let's say I have a list L1 equal to 1, 2, okay, 10, 20, 30, and I access L1 2, so I should get 30. But if I access L1 3, that's a beyond the range, right? L1 3 is beyond the range, so it will throw an exception. So I get an exception called index error and I can catch it also. Basic data types, we have Boolean, true, false, int, float, string. All of them are classes. High level, we have seen list, we have seen dictionary, we have seen. Tuple looks something like this. Let's say it is a record of a person. So it's a record of a person called Ram, and Ram has age 10 and he has weight 46.4 kilograms. His address is Bangalore. So that's a tuple. The only difference between tuple and list is syntactically that tuple has a round bracket, list has a square bracket, but fundamentally they are highly different. Tuples also you can index in the same way, but tuples you cannot modify. List you can modify. If you say T10 equal to Sham, that will be an error because tuples are so-called immutable. Immutable means you cannot modify them. They are read-only stuff. So if I run it, I get a exception type error. Tuple object doesn't support item assignment. I can't assign something in of this read-only immutable object. Tuples are often a good choice for storing an entity. If you know that the entity will have just name, age, weight, and address, you can have a tuple. If you think that the entity will be a highly dynamic entity, for somebody I might have some data, for another I might have some data. For example, you are storing student details and you want to store one student. So how do you represent it? You can represent it as a list where the index specifies what attribute it has, or you can even use a dictionary. You can say that name is Ram, age is 10, weight is so and so, and address is this. And if I ask what is type of D1, it's a dict. If I ask what all can I do on a dictionary, you can do dir dict. Dir is a general thing which allows you to ask what all can I do on this. what all can I do on dict. So if I do it, let's say, I see these are the kind of methods of that class. And you can do it with some variable also. You can say on D1, what all can I do? Because D1 is a dict, I can do all this. This dictionary, D1, let me print it, D1. So I can index it with a key. I can say D1 name. So that's run. So dictionaries are associative arrays. So Boolean, so you have true, false. That's a typical Boolean, nothing great about it. But Boolean also happens to be a class. It also has some methods, right? Everything is a class. And if you want to seek help, Python has tremendously good help. You can say help bool dot that method name, it will give you the help. You have the and, not, or conditions. Integers, we know them since early childhood. So nothing great about it. You can have shorthand, everything, that's okay. Floating points, great. You can work on them. Strings, a little bit interesting. So strings can be in different notations. You can enclose them in single quote. You can enclose them in double quote. Doesn't make a difference. The thumb rule is that if it is a single quote, and so in a single quote, if double quotes come in the middle, they don't create problem. Because I opened it using a single quote, it closes with a single quote. These double quotes don't create a trouble. In a double quote, single quotes don't create a problem. So the thumb rule is if you have single quotes in the middle of the string, you can rather use double quote, and vice versa. There is something called triple quotes also. Triple quotes are multi-line strings. So that means they begin when the triple quote starts and they end when the triple quote ends. So if you want a paragraph with new lines in the string, you can use triple quote, and triple quote can be using double quotes as well as using single quotes. So triple double quotes and triple single quotes. And strings are sequences. We call them sequences. Tuple is a sequence, string is a sequence, list is a sequence. If you go to the Python main website, there is an excellent tutorial. It uses a term called sequences at some place. So anything which is indexable, you can understand it's a sequence. Learn for a sequence, apply to string, to tuple, to list, because all of them are indexable sequences. You can always ask what is the second element of a string, of a list, of a tuple. So they are sequences. And in Python, there is no character data type. Let's say you have a string s1 equal to hello, and you ask s1 0. You get a string of length 1. So if you ask what is the type of s1 0, it will say it is a string. It's not a char or something. So strings are there. You can concatenate them. Strings can be concatenated using plus. If you want to repeat a string 3 times, you can say star 3 into 3 means repeat it 3 times. You can index things. In Python, negative indices are allowed. Whether you have a list, tuple, string, all of them are sequences. So if you say -1, that means the last one. So -1 means I print O. If I say -2, that will be L, -3 will be L, -4 will be E. So I can try that. So that's how it is. So negative indices are allowed in Python. So negative -1 is the last, -2 is the second last, and so on. And if you go too far, if you say -40, it will throw an exception, index error, because whether in the positive or in the negative, you cannot go out of bound. So that's okay. There is something called slicing also in Python. Slicing you can do to any sequence. So I created this s1 and it is a hello world. Now I can say s1, give me all characters starting with 0 and ending at index 3. So when I say start at index 0 and index 3, so I can imagine 0, 1, 2, 3. But the 3 is not included. The range is like start, stop, but the stop is exclusive. It is like closed at the beginning, open at the end. So I should get actually 0, 1, 2, HEL. That's what I should get. So that's okay. And even I can give a step size. I can say that don't take everything, have a step size of 2. That means skip one character. So in that case, I should be skipping this E. And let me run it. And that E is skipped. So the general syntax of slicing is start, stop, step. So you start at a thing that index is inclusive. You stop just before that stop index. So that stop index is actually exclusive. It stops just before that. And you can optionally give a step size. If you don't give, it is 1. And you can do such a thing to everything. You can say even on a list, let's say L1 equal to 5, 6, 7, 8. And you can say L1 start at index 1 and stop at index 3. You get a slice. Okay. Slicing are forgiving. If you say start at L1 and go till index 30, they forgive you. They say that there is nothing till 30, but I will stop at the end. And you can have negative offset, and you can slice in the reverse direction by giving negative offset, all that. You can even omit something. You can say L1 1 onwards. You can do type convergence, all that. There are literals, that's okay. High level data structures we have met, some of them. List we have met. These things can be heterogeneous. List, tuple, they can be heterogeneous. It's not that all elements are of the same type. It's not array of integer. It's array of anything, kind of. So one can be a string, another can be a integer, and yet another can be a list. So if you want a matrix, for example, then you can have a list of list. So lists can be heterogeneous, they can be embedded. In dictionary, you can have embedded list. So if you, for example, if you have a JSON object, JavaScript object, notation object, then you can consider it as a dictionary. And if it is nested, then some attribute of the object will further be list or further dictionaries. So using list and dictionary and nesting them deep down, you can represent a JSON object very conveniently. So indexing, slicing, lists are mutable, tuples are not. Concatenating, so everything carries a natural meaning. Plus means concatenation, whether it is string or list or tuple, they get concatenated. Repeating, so star carries an intuitive meaning that you can repeat that thing, whether it's a string, list or tuple. Iterating, we know. Tuples are like list, but they are constant entities. They are read-only entities. You cannot modify them. You cannot append into it. Once you create a tuple, if it has 3 members, it has 3 members forever. You can nest structures. You can say this tuple has a Ram, Sham 10 and a list called 4, 4, 5. Indexing, slicing, all this we know. Dictionary we understand. They are key value pairs. A key cannot repeat. A dictionary means keys once only. And keys should be immutable. Why key should be immutable? Because ultimately dictionary is a hash table in the background. So you hash on the key. That means whatever key is, you generate a integer index and then you give it to some bucket table. So naturally that key has to be immutable. Iterating, there are different ways. By default you iterate through only the keys. If you want the values, you can use values. If you want both key and values, you can say items. And because items are key value pair, you need to give a tuple here. This k comma v actually is a tuple. Set is like a dictionary. It uses the same mechanism as a dictionary. It uses hash table, it is order 1, all that. But set doesn't have a value, or you can say doesn't have a key, or you can say key and value are 1. The mechanism, the data structure mechanism is same. This key has to be immutable. Behind the scene index table, hash table will be used. With set, you get all those mathematical nice things which you have enjoyed in your early childhood. You can do union intersections. You have something called range. Range is a class. You want to say loop from 0 to 10. So you can say for I in range 0 to 10. If you really want to include 10, then you will like to say 11. Let's say I want to include 10. So for I in range 0 to 11, 11 is exclusive, and I can say print I. So range you can use as a range generator, and you can say that I want to skip, I want a step size of 2. Great. So these ranges are object. If I want to really see the different elements, then I need to either typecast it. I need to say list, convert it to a list. Now that is very interesting. This object is called as a generator object. Generator objects are very small objects. For example, if you say range, let's say 1 million, then that's a small object because the object only says I start at 0 and I stop at 1 million. But if I convert it to a list, that will be a huge list. The beauty of generator objects is that they can be very small and they can generate a large range. Variable names are references to objects. That is a very key thing actually. let's say A is this list 1, 2, 3 and you say B equal to A, then actually A and B are one object but two references. If I add 100 to B0, A0 also changes because A0 and B0 they are the same because A and B are the same object. So you have this object 1, 2, 3 and A is just a symbol. A is just a name affixed here. And when I say B equal to A, B is yet just a name affixed here. So when you access in the code B0, you access this. And when you access in the code A0, you access this. A and B are just two names of the same entity. If you think I'm not saying the truth, you can print the identifier of the object. So you will see that this ID A and ID B are the same. So they are ditto the same, and when you add it to B0, A0 also changed. So even when you get to nested list, maybe it's a matrix. So I say M1 is equal to matrix and it's a 2 cross 3 matrix. So I have first row 3, 4, 5. I have second row 7, 8, 9, just like that. You can draw it like this, that this is two references R1 and R2. R1 is a list 3, 4, 5 and R2 is a list 7, 8, 9. Even in these elements, if you see with a microscope, you will see that these are also references. Let's say I create a L1 equal to 1, 2, 3 and I create a L2 equal to L1, L1. Now if I say L2, that's naturally 1, 2, 3, 1, 2, 3. But if I say L2, 0, L2, 0 will be this list. And I say L2, 0, 0 is equal to 100. So fundamentally, I am changing this to 100, correct? But you will see that this also changes to 100 because ultimately in L2, I store two references and those two references are to the same object. So even this will change to 100. You can see that also changed to 100. So just keep in mind that when you have variables A equal to this, B equal to this, they are references. And when you have list as a sequence of things, those things are also references.
So what is the advantage of that? How they are going to affect memory, execution or storage? कुछ advantage है?
हाँ, right. Sure, advantage बिल्कुल है. तो अभी जब इंडिविजुअल primitives की बात कर रहे हैं तो कोई खास फायदा नहीं है. But when you have big data structures, like you have the entire dictionary of mapping something to something, it's a big one. Then you store something like this. You say that D1 is this dictionary. Let's say key 1 value 10 and key 2 value 20, assume. Maybe you create a tuple. You say tuple T1 equal to D1. Now this tuple is a tuple of references. That means the tuple size, if you think of the object size, is very small. Size worth two references. And if you say T1 0 of K1, you assign it 999. And if you see D1, it has changed. Because T1 is actually containing references to D1. Finally, there are things like shallow copy, deep copy also, right? When you create a copy, when you say T2 equal to T1, T2 equal to T1 करेंगे तो reference assign हुए, कुछ copy बना ही नहीं, क्योंकि T2 equal to T1 means T2 refers to the same object as T1. Copy बनाने का एक method है कि you just slice 0 till a large number. Slice makes a copy, but it makes a shallow copy. And इसका जो elegant तरीका है वो है omit this end index and omit this index also. क्योंकि मैंने बताया slicing में you can omit the start and stop. If you omit both, it starts at the very start, it ends at the very end. This is creating a shallow copy. और deep copy के भी methods होते हैं. There are certain modules. Python में बहुत सारे modules packages हैं. Python का beauty है कि पूरे संसार ने बहुत सारे modules packages PyPy में install किए हैं Python package index. So you can use all of them. If you go to my channel and Python में आप ये देखेंगे, ये वाला variables are references. तो 7 मिनट लगा के मैंने थोड़ा ढंग से explain किया है. So you have if conditions, you can have if, elif, else, all that. For loop देखा ही है हमने. While loop भी होता है, continue होता है, break होता है, all that is there. You can break out of the loop, you can continue, skip part of the loop, all that is there. You can have while loop. अगर आपको ऐसे इंडेक्स बेस्ड करना है तो आप ऐसे कर सकते हो, नहीं तो इंडेक्स बेस्ड फॉर लूप के साथ भी कर सकते हो. देयर इज समथिंग कॉल्ड एनुमरेट functions. You can define functions. They look something like this: def, function name, then some parameters and some statements. They can optionally return a value. You never declare कि किस टाइप की वैल्यू रिटर्न करेगा, क्योंकि अब जब वेरिएबल का ही डेटा टाइप नहीं रिटर्न करते तो फंक्शन का क्यों करेंगे। फंक्शन के जो पैरामीटर होते हैं उनका भी आप डेटा टाइप नहीं बताते क्योंकि इट्स ऑल डायनेमिक, राइट। सो ऑल यू से इज दिस टेक्स 3 पैरामीटर्स ए बी सी, इट टेक्स पोटेंशियली एक्स वाई जेड ए पैरामीटर, यू कैन हैव डिफॉल्ट वैल्यूज, अगर वो ओमिट हुआ तो उसका वैल्यू ये होगा, तो डिफॉल्ट वैल्यू का कंसेप्ट है। फंक्शंस interestingly are objects. That means you can store functions as member of some object. You can transform function and return a new object and all that. तो जो डेकोरेटर्स का कंसेप्ट है कि आपने एक फंक्शन लिया, उसमें यू एडिड समथिंग एंड यू रिटर्न अनदर फंक्शन, तो डेकोरेटर एक्चुअली इज ए फंक्शन विच टेक्स ए फंक्शन एंड रिटर्न्स ए फंक्शन. तो फंक्शन बीइंग एन ऑब्जेक्ट is a phenomenal thing actually. There is something called positional and there is something called keyword arguments. पोजिशनल आर्गुमेंट वो होता है जो पोजीशन से एसोसिएट होता है, जैसे कि ये मोहन है, ये नाम क्यों है, क्योंकि ये 0th एलिमेंट है जो पहला आर्गुमेंट है. 19 एज है क्योंकि वो सेकंड है, इंडिया कंट्री क्योंकि वो थर्ड है. एंड यू कैन हैव सम एडिशनल आर्गुमेंट्स ऑल्सो. जो एडिशनल पोजिशनल आर्गुमेंट है उन्हें समथिंग कोड आर्क्स कैप्चर कर लेता है. Args basically means कि capture all the positional arguments which are not captured by named elements. That tuple takes all the additional things. Keyword arguments ऐसे पास किए जाते हैं. You can call display with the normal plain way जो हमने बचपन से देखा है, या फिर आप कह सकते हैं कि भाई नाम ये है राम, एज ये है, कंट्री ये है, तो मैं किसी भी ऑर्डर में कर सकता हूँ. मैं इसको उठा के मैं कंट्री को पहले रख सकता हूँ. कीवर्ड आर्गुमेंट मतलब जब मैं कॉल कर रहा हूँ या कर रही हूँ तो आई एम गिविंग द नेम ऑफ द आर्गुमेंट एंड देन द वैल्यू, सो दैट्स बिकम्स ए कीवर्ड आर्गुमेंट. क्योंकि मैंने की के साथ उसका वैल्यू दिया तो आई कैन गिव देम आउट ऑफ ऑर्डर ऑल्सो. इसमें स्टार स्टार KW आर्क्स भी दिया है. तो मान लीजिए मैं कुछ और आर्गुमेंट देता हूँ, मैं कहता हूँ कि भाई हैप्पीनेस इंडेक्स इक्वल टू 0.9 लेट्स से. सो नाउ यू कैन सी दैट हैप्पीनेस इंडेक्स इज कैप्चर्ड इन दिस स्टार स्टार KW आर्क्स. स्टार स्टार KW आर्क्स क्या है? कीवर्ड आर्गुमेंट्स. कैप्चर ऑल द कीवर्ड आर्गुमेंट्स विच आर नॉट कैप्चर्ड अदरवाइज. स्टार आर्क्स मीन्स कैप्चर ऑल द पोजिशनल आर्गुमेंट्स विच आर नॉट कैप्चर्ड अदरवाइज. KW आर्क्स मीन्स कैप्चर ऑल द कीवर्ड आर्गुमेंट्स विच आर नॉट कैप्चर्ड अदरवाइज. Tuple unpacking, you have a list and you are unpacking it, or you have a string and you are unpacking it. Let's say मेरा MySum एक फंक्शन है which just takes sum of any arbitrary integers, तो आप इसे समझ सकते हैं. जब भी आप पाइथन में ऐसा कोड लिखें ना, लूप है ret equal to 0, ret plus equal to I, if you ever write such code, you can ask yourself, आप concise कोड नहीं लिख रहे हो, you are writing C programming style code. क्योंकि पाइथन कोड बहुत छोटा बट बहुत पावरफुल होता है. अगर आप ऐसे लूप लिख रहे हो तो मोस्ट लाइकली यू कैन डू समथिंग. देयर इज समथिंग कॉल्ड फंक टूल्स, देयर इज समथिंग कॉल्ड एक्यूमुलेटर्स, देयर इज समथिंग कॉल्ड मैप रिड्यूस. स्टार आर्क्स यहाँ भी यूज होता है. व्हेन यू पास इन आर्गुमेंट वहां पे भी स्टार आर्क्स यूज होता है. वहां स्टार आर्क्स का मतलब होता है कि आर्क्स को एक एंटिटी की तरह मत भेजो कि ये टपल है. एक्सपैंड इट, स्प्लिट इट अक्रॉस आर्गुमेंट्स. KW आर्क्स अगर आप पास करते हो तो दैट मीन्स यू आर पासिंग वन पैरामीटर विच इज ए डिक्शनरी. बट अगर आप उसे अलग अलग पैरामीटर के रूप में पास करना चाहते हो कि जो मुझे पैरामीटर मिले मैं आपको एज ए सेपरेट पैरामीटर ही पास कर रहा हूँ, तो स्टार स्टार आप लगाएंगे. देयर इज समथिंग कॉल्ड कॉम्प्रिहेंशन, लिस्ट कॉम्प्रिहेंशन. जैसे अगर आपको एक लिस्ट बनानी है, लिस्ट ऑफ एलिमेंट्स 1 to 10 into 10, राइट. 1 to 10 लिस्ट को लेके into 10 करना है. तो एक तो मेथड ये है, अगर आप ऐसा कोड लिखो तो टेल योरसेल्फ दैट यू आर नॉट राइटिंग पाइथन, यू आर राइटिंग सी प्रोग्राम इन पाइथन. कॉम्प्रिहेंशन ऐसा होता है, यू कैन से 10 star I फॉर I इन रेंज 1 to 11. तो इसको लिस्ट कॉम्प्रिहेंशन कहते हैं. तो बेसिकली एक एंगल से आप देखें तो बिल्कुल सेम कंस्टिट्यूएंट हैं. पहले 10 star I आ गया और फिर ये आ गया फॉर I in range. Syntactically you can relate it that you are writing the for loop with the body first and then the for loop. इसी तरह टपल कॉम्प्रिहेंशन, डिक्शनरी कॉम्प्रिहेंशन, सेट कॉम्प्रिहेंशन सब है. इतना ही नहीं, आप ये भी कर सकते हैं. आप कह सकते हैं कि x, y फॉर x इन रेंज 1 to 3 मान लो रखना चाहता हूँ, 1 to 4 लिखता हूँ. एंड फॉर y इन रेंज 10 to 11 रखता हूँ, तो यहाँ पे 12 लिखता हूँ. ठीक है. तो मैं सारे कम्बिनेशन जनरेट कर रहा हूँ. x, y, x रेंज ले रहा है 1 से 3 में, यानी कि x के 3 वैल्यूज, y ले रहा है 10 और 11 2, तो 6 कम्बिनेशंस बनते हैं एंड यू कैन जनरेट दैट. सो इन दैट सेंस पाइथन, नमपाई, पांडा, स्पाइस पार, जब भी आप वहाँ जाएंगे आप देखेंगे इतना सा कोड है बट डूइंग अ लॉट. these are some very good references. You can be in touch with me if you go to the website and if you see this upcoming batches, there is a calendar. इसमें एक चीज़ मैं जस्ट मेंशन करना चाहूँगा कि अभी ये 1 घंटा था तो कुछ ज़्यादा तो खैर हो नहीं पाया. नॉर्मली ये 1 महीने में होता है. 1 महीने में मैं थोड़ा डेटा साइंस भी डाल देता हूँ. 1 डे भी है September 23 को. I hope at least it created some interest and it gave you a glimpse कि Python बहुत beautiful भी है और बहुत powerful भी है.